Hi again, everyone. Dr. Tom McNamara here for our course in college algebra. We are continuing our work with rational functions. In this video, I wanted to look at a couple of examples where we basically do everything and go ahead and take the formula and graph the rational function. So we're going to focus on a couple of key ideas. That's all we really need. We'll need to identify the vertical asymptotes, figure out how the function behaves at those vertical asymptotes, and then lastly look at the horizontal asymptotes and kind of put this all together and draw a graph. So let's jump into an example. And we'll graph f of x equals negative 2x over x plus 5. Okay, so to find my vertical asymptotes, I hone in on the denominator of my function. Okay, so x plus 5 equals 0. What x value makes that true? Easy to solve. X equals negative 5. So I have a vertical asymptote at negative 5. All right. I'm going to check the behavior of the function at negative 5. I'm also going to kind of start drawing my graph over here, putting in the information that I know. One, two, three, four, 5. Okay, so I'm going to put a dashed vertical line right there. That's x equals negative 5. The reason I'm making it a dashed line is because a vertical asymptote isn't really part of the graph. It's more of like a boundary on the graph. It's a vertical line that the function's graph cannot cross. Okay, now when I say behavior check, remember we made that little sign chart a few videos back? Okay, so I'm going to do this. I'm going to put my sign chart right under my graph. Okay, negative 5 is an important place. So that's where the vertical asymptote is happening. So I'm going to check how the graph is behaving on each side. And I'm also going to check 0. Okay? When you're making your sign chart to understand how a rational function behaves, you should look at places where both the numerator and denominator are 0. Okay, so I'm going to pick some test points, which is our usual procedure. I'll just pick 1, something bigger than 0. And I will also, let's see, something between negative 5 and 0. Now I'm really concerned about what's happening around negative 5, so maybe I'll do like negative 4.9 and negative 5.1, just to get an idea what's going on here. Okay. So, I take my test points. I plug them into my function. Remember, I don't really care about the exact numerical value that I'm getting. I care about the sign. If I take negative 5.1 and put this in, okay, up top, I get a positive. Downstairs, I get a negative. Okay, so positive up here because I have a negative 2 times the negative 5.1. And downstairs, I have negative 5.1 plus 5. Well, it's going to be negative 0.1. So my numerator is positive, my denominator is negative. So the whole thing there is negative. Okay, now let's look at this. Negative 4.9. Numerator, once again, is negative times negative. So up top, we got a positive. Down below, we got a positive. So we got a plus there. Negative, positive. Remember the 4 different types of behaviors? You could go both up, you could go both down, you could go like that, you could go like that. Okay? It looks like in this case we have that scenario. negative, and then positive at my vertical asymptote. Now, okay, let me check what's happening over here. If I plug in a 1, negative over a positive, so that's negative. Okay, great. Now, so I got my behavior check done. Now my horizontal asymptotes. You'll remember from our last video that the horizontal asymptotes of these rational functions are determined by looking at the degree of the numerator versus the degree of the denominator. With this function, we see both of the parts, the numerator and denominator, are linear. They're both degree 1, so they have the same degree. You'll have a horizontal asymptote at the ratio of the lead coefficients. Up top, the lead is -2. Downstairs, the lead is 1. Ratio of the lead coefficients is -2. So we will have a horizontal asymptote at y equals -2. Okay. So, what's going to be happening here, I'm not sure I'm going to get a great picture, but something kind of like this. Okay? My horizontal asymptote basically tells me where the graph flattens out to. Okay? So I've got to flatten out towards y equals -2. That's why I'm kind of going through here. Now, the reason I know I go through here is because that's where my numerator is 0. So that's going to be your x-intercept. Okay, and what's happening over here is I'm going to have this kind of behavior here. Okay? Following my behavior check, I know the graph's got to go down there and up there at my vertical asymptote. So this behavior here. And I know over here I go toward my horizontal asymptote. So that's a quick sketch of the graph of this rational function. So the key ideas, if you're asked to graph a rational function on a quiz or a test, is where are those vertical asymptotes? And remember, for those, we're looking at the denominator. Where's the denominator 0? Do a check on the behavior, because remember, you could do this, you could do that, you could do this, you could do that. Okay, you have 4 possible cases. How do you distinguish? Use your sign chart. Okay? And then get your horizontal asymptotes, put all this together, and you get the picture. Okay, one more. So one more example. Okay, so for this next example, we're going to do f of x equals x plus 1 over x squared minus x, x squared plus x minus 6. Okay, so x plus 1 over x squared plus x minus 6. So we're looking for our vertical asymptotes. That always involves solving an equation. X squared plus x minus 6 equals 0. So we factor into x plus 3, x minus 2. So this graph is going to have 2 vertical asymptotes as opposed to the last graph, which only had 1. So I'll get my picture going here. So I will have a dashed vertical line here at x equals -3. I'll have another dashed vertical line here at x equals 2. Okay, so for a complete graph of these rational functions, we want the asymptotes drawn in there on the picture. We also want them labeled. This is a pretty easy one, so I'll go do this right away. The horizontal asymptote is y equals 0. How do we determine that? Well, we look at the relative degree of the numerator compared to the denominator. Numerator is degree 1, denominator is degree 2. Denominator has the bigger degree, so horizontal asymptote at y equals 0. That's case 1 from our last video. Okay, so this is our horizontal asymptote right here. I'm going to draw it in. It's the x-axis. Okay, now we do this behavior check. Okay, following our last video, I'm going to do it right underneath my graph so I can kind of transfer the important information. Okay, so the important points for me to test are the places where I have vertical asymptotes, -3 and +2, and also where the numerator is 0, which is -1. Okay, so I'm going to need 1, 2, 3, 4 test points. 2.1, 1.9. I try to pick test points that are like pretty close to the places where I have vertical asymptotes. Here I'll put 0. I want something on either side of this, so I guess we're actually okay. -2, let's make that -2.9, -3.1. Okay, so I'm going to test those points. Now remember, we are not testing to get an exact numerical value. We're checking the sign. This is kind of a sign chart to give us an idea of how the graph behaves. Okay. And I would basically recommend using the factored version. Okay, so I'm going to replace my denominator with the factored version of that polynomial, x plus 3 times x minus 2. Okay, so I plug in 2.1. Plug in 2.1 for x. Up top, that's positive, that's positive, that's positive. All 3 components are positive, so the result is positive. You plug in 1.9, let's see what happens. Positive, positive, negative. The result is negative. Okay, so we got that behavior going on at this vertical asymptote. Down on this side, up on this side. Okay. -1. Okay, if I plug in 0, positive, positive, negative, so I'm still negative there. If I plug in -2.9, negative, negative, positive. So I got a positive there. -3.1, negative, negative, negative. 3 negatives gives me a negative. Okay, so a couple things happening. My graph is going to be plummeting down over here and zooming up over here. I have an x-intercept at -1. How do I know that? It's where my numerator is 0. Okay, so on my sign chart, I got vertical asymptotes and x-intercepts. So I'm going to have this business right here. And how do I know I drop down here? Look at that negative. Negative means the graph is dropping. And over here, I got this behavior. Let me finish it off here. I know I need to flatten out toward my horizontal asymptotes. So, that is our sketch for the graph of this rational function. Pretty quick to draw the sketch. Notice we're not doing a ton of number crunching. I'm looking at the key features, which are the asymptotes, and I'm looking at this sign chart to see what happens near the asymptotes, particularly the vertical asymptotes. I know for my horizontal asymptote, as x gets bigger, I have to flatten out toward my horizontal asymptote. Okay, so get some practice with the exercises I've assigned, and you should have this down pretty quickly for graphing rational functions. Okay, we can get a lot of information by knowing those asymptotes and making this sign chart.